Welcome to our podcast, where we bring you fascinating stories. In this episode, we explore FireDrone, the heat-resistant drone built for extreme environments. In the past decade, drones have revolutionized almost every space, from military aviation to commercial uses like photography and videography. Their shortcomings, like any other machine, followed by better updated versions, made the use of drones inevitable in the near future. One such drawback in the usage of drones was that they can tolerate only a certain temperature, rendering them unsuitable for use in several operations, particularly hazardous ones, where it would have been very useful and helped save lives and valuable material. Suppose a building is on fire, with flames coming out of the windows and doors. As the firefighters arrive at the scene, no one knows who is left inside, the layout of the building, the availability of emergency exits, and which areas are still safe. To go inside a building with a huge fire can even put firefighters at risk. In such cases, a drone can be of great functionality, provided it can withstand extremely high temperatures. Under a joint project, the Imperial College London and Empa, the Materials Science Unit of Swiss Federal Laboratories, have developed a remotely controlled flyer that is capable of enduring the temperatures of a gas flame, simulating the conditions of a forest fire or building-based disaster. The prototype drone, called FireDrone, could be flown into burning buildings or woodland to assess the hazards and provide crucial first-hand data from danger zones. The data would then be sent to first responders to help them in emergency response. Principal investigator Professor Mirko Kovac, director of the Aerial Robotics Lab at Imperial College London and head of the Laboratory of Sustainability Robotics at Empa, said, "Until they enter the danger zone, firefighters can't be certain of what or who they'll find and what challenges they'll encounter. FireDrone could be sent in ahead to gather crucial information, noting trapped people, building layouts, unexpected hazards, so that responders can prepare accordingly to keep themselves safe and potentially save more lives." In the past, drones have been used in firefighting to take aerial footage, hoist dire hoses up skyscrapers, or drop fire retardants in remote areas to slow the spread of wildfires. However, current drones developed for firefighting are unable to fly much closer to burning material as their frames start to melt and their electronics fail. To find a solution to this problem, researchers looked to nature for inspiration to devise a means of maintaining a functioning internal temperature in extreme conditions. Deploying robots in extreme environments provides great benefits to reducing risks to human lives, and who better to look to than animals that have evolved their own ways of adapting to these extremes, using inspiration from how animals keep cool in the heat, said Kovac. Animals like penguins, Arctic foxes, and spittlebugs, which live in extreme temperatures, have appropriate layers of fat and fur. Some animals even produce their own layers of thermoregulating material that allow them to thrive in extreme conditions. To create a fire-resistant drone, researchers used the same concept and created a protective structural shell made of lightweight, thermally super-insulating materials like glass fibers and polyimide aerogel. They also coated this with super-reflecting aluminium to reflect heat. Within the protective exoskeleton, the researchers placed temperature-sensitive components such as regular and infrared cameras, carbon dioxide sensors, video transmitters, flight controllers, batteries, and radio receivers. They also used the release and evaporation of gas from the carbon dioxide sensors to build a cooling system to keep temperatures down. The researchers flew the drone in temperature-controlled chambers before exposing it to open flames at a firefighter training facility, showing that it could tolerate temperatures of up to 200 degrees Celsius for 10 minutes. Cold temperatures can be just as punishing for electronics, so the team took to a glacier tunnel in Switzerland to test performance in an icy environment. The insulation kept the extreme cold from penetrating the components, while the heat generated by the whirring motors and electronics kept the batteries within their operating range. The tests confirmed FireDrone's potential to withstand dangerously hot and cold situations, but it is just a prototype so far. Before the drone can zoom into burning buildings and search freezing crevasses for injured ice climbers, the team hopes to improve its versatility and equip it with additional sensors so it can feed more essential information back. The application of drones is often limited by environmental factors like temperature. We demonstrate a way to overcome this and are convinced our findings will help to unleash the future power of drones for extreme environments, said Kovac. Thank you for listening to our podcast. We have many more such compelling episodes for you. Enjoy them. Do share your opinion in the comment box and subscribe to us for more.